In lesson 6-4, we will continue working with proportions, only now we're going to relate them to similar figures. Now, a similar figure is one that has all congruent angles. So if you look at these two triangles here, this is a right angle. This is also a right angle. This angle here is congruent, meaning it's equal to that angle. This angle would be congruent to that angle. Okay, so these are characteristics of similar figures. Now, about the sides, obviously the sides are not the same length, but they are proportional, and that's where our proportions come in here. If the sides weren't proportional, then we cannot call them similar figures. So if you have similar figures, you have to assume that the sides are proportional. Now, just like with our last assignment here, we need to match corresponding parts. That's the key part here. Okay, so if I look at corresponding parts, this side here is the shorter side, matches with this shorter side. So what I'm going to do is I'm going to say x over 30. Okay, now I put, let's call this triangle 1, and this, maybe let's just call this triangle 2. So I put triangle 2 on top. So that means this 4 has to go on top because I got to match those corresponding parts. Now what matches with the 4? The 40 does. Okay, now once I'm to this point, I just cross multiply. So I'm going to get 40x is equal to 120. And I divide both by the coefficient, which is 40. So x equals, now in this case, you could cross off the 0, and 12 divided by 4 equals 3. Now, most of the time we would want to include a label here, but there aren't any labels with these at all. So I'm fine with you just saying 3, or maybe you could say 3 units. Since there isn't a label, you could include UN for units. So the number 3 here makes this a similar figure. Going on to the next one, again, you want to match corresponding parts. So I'm going to put x over 63. And then I'm going to put 12 over 108. Okay, again, my smaller rectangle, both parts are on the top, and x is a smaller side, and it matches with 63. So everything is corresponding. Now we need to cross multiply to get 108x equals, and if we can go ahead and put that in your calculator, we get 63 times 12 equals 756. Divide by the coefficient of 108, and we get x is equal to, so we'll just go ahead and divide by 108, equals 7, and we can say 7 units again. Okay, now it doesn't really matter if I put the x on the top or on the bottom. Really, there's about 4 different ways you could set up a proportion in order to solve it. I'll show you another way here in the next example. All right, so how I was doing it before is I was putting x over 7. Now, you could also just do x over 132, so let's try that. Or you can even put the x on the bottom. Let's go 132 over x. Okay, so notice I put the same shape's measurement in the same ratio. Now, what goes with 132? Would that be the 7 or the 11? Well, the 11 matches with the 32, so I'm going to put 11 on top, and I'm going to put the 7 on the bottom. Now, once you get the proportions set up, you just cross multiply. So I get 11x is equal to, and 132 times 7 is 924. And we'll divide that by 11. That way x is equal to 84. And we can again say 84 units because we are talking about a distance here, so I do like to have a label. But since they're not giving us a label, we can just say 84 units. All right, so now it gets a little bit trickier because the shape is turned. But again, we still want to match corresponding to corresponding. So this time I'm going to say 5 over 55 is equal to, now what goes with the 5? The x goes with the 5. So I'm going to say x over 121 because the 55 and the 121 go together. Now we can cross multiply to get 55x is equal to, now we have to do 5 times 121, which is 605, divide by the coefficient, and we'll have x is equal to 11 units. Okay, so again, remember, for a similar figure to actually be similar, you have to have congruent or equal angles and proportional sides. So what we're doing is we are making it proportional. Okay, so 5 times 11 is 55, and 11 times 11 is 121. So it's the same ratio. Okay. All right. Same thing here. We need to determine which ones are matching. Okay, it gets a little bit trickier when they're turned, but obviously the x and the 27 go together, and the 11 and the 99 go together. So now you just need to determine how do you want to write it. Well, let's try 99 over 27 is equal to, okay, what goes with the 99? The 11 does. The 11's the bigger side, so we'll go 11 over x. Now let's cross multiply, so I get 99x is equal to, now I got to do 11 times 27. 297. I need to divide both by the coefficient, which is 99 in this problem. And so that side x is going to be 3 units long in order to make this proportional or similar to that one. All right, my last example here. In this case, I know that I have a 30 and a 30 and a 6 and an x. So we can go ahead and write x over 6 equals 30 over 30. Now, in this case, you should hopefully just be able to notice that, okay, these are the same, so these obviously have to be the same. So x should just equal 6. But if you want to, we can cross multiply, and we get 30x is equal to 180. Divide both sides by 30, and we would get x is equal to 6. Okay, because we cross the zeros off, and 18 divided by 3 is 6. So 6 units, or we can say just 6 units here. Again, a good way to show this is just to be like, well, 6 times 5 is 30, so what times 5 is 30? Well, obviously just 6. So you can skip a step if you do notice that there's a pretty nice relationship you're going, that these are both the same. We actually call these triangles isosceles triangles when they have two sides the same length. Okay, and that's our last example for today. So remember, just match corresponding parts and then cross multiply and divide.